Good morning, everyone. How are you all? I hope all are doing good. So, after the holidays, this is my first class. So, I would like to start with the modern physics. So, the modern physics is one of your physics paper, and in this modern physics, I am going to start with unit 3, that is nuclear physics. Okay, so this is a very new concept that I am introducing today to you people. So, that is why I would like to share some history regarding this nuclear physics. Okay, listen carefully, all of you. So what is nuclear physics? What is nuclear physics means? So which is very quite simply, nuclear physics is a study of atomic. Okay, Nana, it is simply the study of atomic nucleus. Okay, however, it is a quite distinct from the branch of physics. Okay, as of now we have not known about the nucleus. Okay, so now I am introducing the new term, that is atomic nucleus. It is completely the study of atomic nucleus. Why? Because in this nuclear physics we are going to study completely about the behavior of atoms. Okay, the behavior of atoms and atomic structures and the interaction of atoms with each other. Okay, atomic structures and next behavior of atoms and interaction of atoms with each other. So in nuclear physics we go into a deeper and deeper level. So in this case the nuclear of an atom, in this case the nuclear of atoms we are going to study. Okay, now this branch of physics as a distinct branch emerged around 100 years ago. Okay, this is the 100 years ago only discovered by the different scientists. 100 years ago only, very historic discoveries that to be placed at that point. For example, the discovery of radioactivity. Okay, the discovery of radioactivity. Okay, Nana, the discovery of radioactivity by Henry Becquerel in the year of 1895, and the lot of discoveries was done by Marie Curie. Already we know this name, who has got Nobel Prize in physics as well as in chemistry. Marie Curie, and his husband name was Pierre Curie. Okay, so Marie Curie and her husband name was Pierre Curie. So these are the scientists discovered this radioactivity phenomenon in the year of 18th century. So this is a very different phenomenon. Okay, this radioactivity phenomenon is a very different from other kind of chemical phenomena, and which was to be observed at the time. For example, a material undergoes a radioactive decay. What will happen to that material? Okay, you see that material undergoes change in the elemental nature of itself. Okay, if a material undergoes a radioactive decay, what will happen to that material? The material undergoes change in elemental nature itself. So the very element that makes of a material undergoes changed. Okay, that is what about the radioactive decay. Now that is what about the radioactivity invention by different scientists. Now see, so at that point of time, that is at the year of 1895, this is the very different, this is very quite different phenomenon that is discovered. Okay, that is what radioactivity. This is a very different chemical processes that understood till that point of time. Now coming to the next point, after the 1895 year, then what will happen? A discovery of electron. Okay, the discovery of electron was occurred. Electron discovered by J.J. Thomson. After the completion of radioactivity phenomenon, after the year of 1895, the electron was discovered by J.J. Thomson. Electron was discovered by J.J. Thomson, and which reveals that the atom itself have some kind of structure. Okay, this after the invention of electron, it reveals that the atom itself having some kind of structure. Okay, till that point of time we had no idea what was the structure of atom. If if at all the atom could be broken into pieces, what will happen? What is the structure of the atom? We don't know exactly what is happening inside of the atom, what is happening around the atom. We don't know exactly at the discovery of electron, okay, at the time of discovery of electron. So J.J. Thomson discovery of electrons reveals that the atom is made up of particles, okay. The atom is made up of, after the discovery of electron, it is decided that the atom is made up of particles like electrons and some kind of internal structure of its own. Atom is made up of particles and some kind of internal structure of its own, okay. And next, like electrons, following this, after almost around the year 1905, okay, our hero Albert Einstein came into the picture, okay. The very famous scientist Albert Einstein, okay. There was a series of papers published by Albert Einstein in the year of 1905, okay. There was a series of papers which was published by the Albert Einstein in the year of 1905. In that, one groundbreaking discovery of which came out from the brain of Albert Einstein is Einstein mass energy equivalence. Einstein mass energy equivalence, that is E is equals to mc square. After the discovery of this relation, there is one bomb blast, already we know, very famous bomb blast, that is at Hiroshima Nagasaki in Japan, okay. Hiroshima Nagasaki bomb blast in Japan, okay. This is completely based on the Einstein mass energy equivalence, okay. After the discovery of this only, the atom bomb should be placed in a Hiroshima Nagasaki at Japan. So that is a very dangerous bomb blast at the World War II, I think that is World War II. At the time of World War II, atom bomb should be taken place at the Hiroshima Nagasaki, okay. So this completely major damage was occurred. This is because of E is equals to mc square relation, okay. That is another point, okay. Coming to our point, okay Nana, this is about 1905 year. Next, coming to the year 1911, okay. So after 5 years, that is around 1911, so group of scientists called Rutherford and his Ernest Rutherford, full name is Ernest Rutherford, okay. In the year of 1911, Ernest Rutherford and his students, okay, students were named as Giga and Master and some other called different names. So they performed a series of experiments in which they bombarded a gold foil with a certain kinds of alpha particles, okay. Alpha particles, they bombarded a gold foil. This is, for example, a gold foil with certain kinds of alpha particles, okay. Alpha particles are bombarded with a gold foil, okay. This is the experiment done by the Rutherford and his students. And next, what will happen by this experiment? Some of the alpha particles are deviated, and some of the alpha particles are bombarded and coming back, okay. Like this happening in this experiment, okay. Like this, the series of experiments are done by this team, and for the first time he has given a planetary model of the atom. After the discovery of different series of experiments, after the completion of series of experiments, he concluded that, okay, he concluded that he has given a planetary model of the atom, that is planetary model of the atom. Who has given, Nana? This is given by Rutherford and his team, okay. Planetary model of the atom. This planetary model of the atom exactly like our solar system, okay. What is our solar system? Sun is at center and all the planets are revolving around the sun. Like that, the atom is at the center and the electrons are revolving around the atom, okay. This is what the planetary model of the atom given by the Rutherford, okay. So in this experiment, for the first time, the atom was compared to the planetary model of the solar system. Now in this case what will happen, the sun around, in this case the sun is its center and all the planets are revolving around the sun. So like that the electrons are revolving around the sun. Now in the same way Rutherford say atom has electrons. Okay, atom already I have told that is atom has electrons, so which revolves around the nucleus. So what is known as tiny and very dense positively charged nucleus. Okay, this is what Nana nucleus, positively charged very tiny and very dense medium called nucleus. Okay, according to Rutherford, the nucleus is at center and the electrons are revolving around the nucleus, positively charged nucleus. Since you can also has a discovery of neutron. Okay, after the completion of this you can also have a discovery of neutron. Who discovered by neutron? Neutron is discovered by James Chadwick. Okay, very important, you have to remember the author, you have to remember the names of the scientists who discovered electron. Electron was discovered by J.J. Thomson. Okay, J.J. Thomson. And next neutron was discovered by James Chadwick. Okay, you have to remember the fundamental particles of the names of the scientists who discovered the fundamental particles. Okay, now okay Nana, so after the discovery of neutron by James Chadwick, you had the Yukawa's theory of nuclear forces. Okay, you had the Yukawa, he is also scientist, Yukawa theory of nuclear forces, Yukawa theory of nuclear forces. Okay, and he is trying to explain this, Yukawa is tries to explain how nuclear forces are together to bound the nucleus. Okay, how nuclear forces are together to bound the nucleus, and lots of other things were explained by the Yukawa, and that created a very distinct branch of physics. Okay, finally this complete portion from the atomic nucleus. Okay, where we can get the atomic nucleus, how atomic nucleus came into the picture. Okay, 100 years ago only the discovery of radioactivity. After radioactivity by the Henry Becquerel in the year of 1895. Next Marie Curie and Pierre Curie came into the picture. Next electron discovery came. Okay, so like this, after this complete discovery of the branch of physics is known as nuclear physics. Okay, this is what nuclear physics, this is what some of the basic concepts regarding the nuclear physics. So now I am entering into our chapter. Okay, now I am entering into our degree chapter, that is nuclear physics. Okay, so to explain the nuclear physics there are two point of views. One is theoretical explanation. Okay, theoretical explanation, and next experimental. Okay, theoretical explanation and experimental explanation. Okay, theoretical means first it is theoretical. In this theoretical also I am going to divide the topics. So first one is nuclear properties. Okay, you have to know what are the properties of nucleus first. Okay, properties of nucleus means it comes under, properties means it will give you what is the size of the nucleus, you don't know, right? So what is the size or radius of the nucleus, you are going to know the size or radius of the nucleus. And next, what is the mass of the nucleus, and next what is the charge of the nucleus, next what is the spin of the nucleus, and what is the angular momentum, right? What is the angular momentum, and next what is the magnetic momentum, what is the angular momentum, and next what is the magnetic momentum. So all these things comes under the nuclear properties. Now coming to nuclear models. Okay, now coming to nuclear models. What are the different kinds of nuclear models in this nuclear physics we are having? So nuclear models means we are having shell model. Okay, what is shell model? Shell model gives the existence of magic numbers. It gives the existence of magic numbers. So I will explain clearly when the topic will come. So just listen carefully. Nuclear models. Nuclear models means shell model. Next liquid drop model. Liquid drop model, shell model, and liquid drop model. Next one is Fermi gas model. Okay, Fermi gas model. These are the three models comes under nuclear models. Now coming to next one is radioactivity. What is radioactivity? That is what our next unit. Total radioactivity comes under the complete unit, that is unit 4th. So in that unit 4th we are going to discuss about complete radioactivity picture. Okay. Now experimental means what is exactly happening nowadays. Okay, so scientifically we are what we are doing what we are experimenting with the electrons, protons, neutrons nowadays. That is what about experimental concept of nuclear physics. So now we are doing only the theoretical part. Okay, we are going to study all these things in this unit 3. Thank you, Nuna.